Good morning, good afternoon, good evening, everybody. Thank you for joining this episode of Conversation with OLI Experts. Today, it's my pleasure to speak with Arjun Ramesh, who is the product manager for OLI, who's leading our product strategy and vision, as well as development activities for us. He's going to talk to us today about the cloud platform, and I wish you a very warm welcome, Arjun, and so glad to have you on this episode of Conversation with OLI Experts.
Thanks, Puneet. Happy to be here.
Can you share sort of what really is the OLI cloud platform? What are some of its key capabilities?
Yeah, absolutely. We have the web APIs or the OLI cloud APIs, and then we have the OLI application builder. So when it comes to the cloud APIs, these are essentially just RESTful web APIs that exposes OLI's core functionality. So you can think of them as the building blocks of OLI that you can kind of build on to make more complex applications, right? The two core ideas in the API space that we have is the OLI engine APIs and the OLI corrosion APIs. On our application builder product, it's a little different. So here we're actually consuming the APIs to build out a web UI. The core idea behind the application builder is essentially we build flow sheet based applications and run it on the cloud. So if those of you are not familiar with what OLI flow sheet is, it's our flagship product for designing and building process simulation capabilities. But the app builder takes it a little step further by saying you can build and design your application in flow sheet, but now you can publish and run on the cloud.
And how is this relevant, right? We're hearing a lot of buzz about digital transformation and what's happening, industrial IoT and things like that. So where does this fit in that broader context as well for our clients?
With respect to the APIs, we made it very easy to access it. We have provided beautiful documentation, and the whole input and output of the system is modeled in JSON, which is like the ubiquitous data interchange for web systems. So this kind of democratizes the simulation itself on the field, where you can kind of give a link to somebody on the field and they can just plug in the numbers and hit run and see the results immediately. So it kind of moves the simulation from just being on the R&D side to more on the operational side. So it kind of leverages that portion here.
Excellent. So talking a little bit on some of the key examples as well for how the cloud offers, scale and economics and things like that, which really become very important for anytime, anywhere, access by any type of user.
It offers several advantages to the end user, right? There's almost zero cost to maintain this whole thing. Essentially, the clients never have to run their own infrastructure, never have to wait for any upgrades. Any updates pushed by OLI is immediately available to them. So things like that. And obviously, the whole developer and ecosystem partnership becomes more frictionless in a sense, because they don't have to maintain their infrastructure and services. We can scale up and down as necessary, and they just focus on their end application.
I understand that our platform today runs on AWS. Can you talk about why you picked AWS as well?
Yeah, absolutely. People who do not know the acronym, it's Amazon Web Services. And the reason we picked AWS is, first of all, number one, it's the most mature of the lot. It provides a plethora of services that we can use for various applications. And it kind of gives the best developer experience in one sentence. So that's usually the go-to service. And partner cloud platforms are just picking up to AWS. So we decided to go with something that's true and tested.
Can you give us a little bit of feel for the high-level cloud architecture? What are the building blocks?
And so in terms of a high level, we have like 4 primary layers here. So we have something called the authorization layer. So this is essentially how someone would log into our OLI cloud. And then we have the services layer. What it essentially is kind of the data highway for our platform. All of the requests and response that the OLI cloud works on flows through these services. It kind of manages the whole thing. And then we have the third component is the data layer. So the data layer is where all of our data is housed, some being temporary, some being permanent. And we've completely made it in a way that the user has complete control over the data. They can choose to upload it, they can choose to delete it, and kind of gives them a layer of control that is typically not attributed to these systems. And then finally, we have the most important bit, which is the computation layer. This is where our OLI engine is housed. So it's the same engine, the same trusted engine that's used in our desktop products, but now housed in this layer. So this whole thing is coordinated in these four layers.
Excellent. So can you talk to us a little bit about how does this work in action? So how can we visualize sort of what happens, right? So can you give us a little bit of, showing the API in action in terms of how the calls take place, how the flashes happen,
Sure.
and where data is passed, and so on. That way we can kind of conceptually visualize how the actually engine can be called, by literally sort of any end application, right? Or program that can actually call this.
Absolutely. Yeah, that's the whole idea of the web APIs. Any program, any application, any operating system, any platform is able to kind of leverage this. Why? It's just because it's simply based on the same things that we use daily. For example, when you go to www.google.com, you get the Google web page. You don't care where it's hosted. So this is the same concept that we've used here. And I'll kind of go over the quick way of how a simple calculation is done to kind of convey the essence, if that's okay. In a nutshell, it's just a bunch of HTTP calls, right? So as obvious, if you use any service on the web right now, you have to log in. So like you have to log into Google Mail, you have to log into OLI web service. So typically the user is issued a username and password. They send it to an authorization endpoint on our end, and they're issued something called the JOT or the JWT. So the JWT is just a mix of letters and numbers that kind of encodes the user's permission level. So it's almost like a ticket into the OLI services. And this is how we also enforce security, because this token is kind of tamper-proof and time-dependent. So you can't use it forever. You got to keep refreshing it. And that's our security model. The second piece I already mentioned to earlier is the user has to somehow upload their chemistry model to the cloud. And this is again done by a standard HTTP service. It's just a post request. They create the DBS file locally using one of our desktop tools, Chemistry Builder, Flowsheet, or Chemistry Build, or OLI Studio, for example, and then upload it to the cloud. So when you do that, you kind of get a receipt saying that this is the ID of the file they've uploaded, and now you can use this ID to kind of run calculations on it. Okay. And the third piece is pretty obvious. The most interesting piece is to actually run the calculation. So now that you have the ticket to OLI, which is the JOT, and you have the file that you uploaded, now all you need to do is, just look into the developer documentation, get the specific input for that calculation, combine all the three together, and make a call. And when you do this, it'll go to the server, and you get your response back in JSON. So that's how it fits together. This is beautifully documented in our documentation, and there's about 15 to 20 calculation types, each slightly different. And you can just put it together essentially. Yeah.
Very, very interesting. I think it's come a long way from the legacy API technology to ease of use and flexibility and scalability. And it's really exciting to see how we're getting our sort of 50 years of intellectual property now being unlocked, in a very simple, easy manner to be able to consume that technology.
This way, you kind of lower the entry barrier for people to use our OLI flowsheet solution, and you can kind of have really high throughput studies. You can create several different apps with several different variations quickly, and you can have also a sort of decoupling between the designer who's deep knowledge of the plant itself, and the person who is interested in changing numbers and seeing what's happening on the plant floor. So that's kind of what we're trying to get with the application builder, is to quickly leverage what if scenarios, and things like that, if that makes sense.
Excellent. And this is really putting the power of electrolyte technology into sort of the field operators, field engineers, right, who may not necessarily be experts in thermodynamics and kinetics and electrolyte modeling, but they really very much focus on the process and driving improvements to the actual operation environment. So that's definitely very fascinating.
It's in a way running the same trusted engine that you used to run and you used to in OLI flowsheet, but right now on the cloud with a lot of hidden layers, because it's all abstracted away for you. In the end, all you see is the change of the output with respect to the inputs that you made.
So clearly, I mean, we've done a lot of work. This is, we do have a very complex engine, right, which has got 50 years of technology innovation in terms of all the computational models and numerical algorithms. The question for you really is, I'm sure there were a lot of challenges along the way. How did you navigate them? Were one or two things that stood out? And can you share any insights on that, Arjun?
Yeah, absolutely. This was probably the most rewarding experience, because I think it came down to essentially merging the old with the new, Vineet. Because number one, you need domain specific expertise. Number two, you need platform specific expertise. So the first thing we had to kind of solve is, how do you have a clear separation of concerns between the web developers, who built out our cloud platform, but leveraging what we already have. So that was the hardest thing. So the way we did that was the architecture that we followed was, let's just put a very nice wrapper around our engine using JSON. That's the first thing we saw. We took all our services and put a JSON wrapper on it. The second thing we did is, as you already know, OLI is famous for having a lot of things. We have our thermodynamics, we have our corrosion modeling, we have our flow sheet modeling. So all these were disparate pieces. And again, on the web development world, if you want to scale, you can't keep creating a new service for each type. So what we did was create one unified service that kind of scales. So now all I have to do is on the website is, okay, here you go. Here's one service. It does corrosion, scaling, flow sheet calculations, and any new thing that we incorporate in the future. So this way we are able to solve the second issue of scale, where we could clearly just build one service, unify all of it together, and give it to the end user. Most important, even though we took our time in doing this, we kept modularity in mind, because we know the future is multi-cloud. We might have to use services, for example, from GCP, Google Cloud Platform, or Azure, and clients might request their data sources to be there, if possible. And if you if you build your architecture in a way that is not amenable to that, then you're kind of locked into AWS and you can't scale. So we kept modularity in mind and wrote all our base infrastructure in an abstract sense.
Excellent. No, that's truly innovative, and I think you've been really adept at some of these sort of nuances of building the cloud platform. So finally, Arjun, can you give a little bit of a view of the vision of where are we going, what's new to be coming? I know we're days away from making the V11 release and the cloud platform available, the sort of the first phase of the cloud platform. Where do you see this going as we evolve the capabilities? And I understand we'll be operating in a very lean, agile manner where we'll have new updates, more frequently, with kind of a DevOps type of setting compared to our traditional Windows-based product, which we are currently on an annual release cycle. So can you talk a little bit about what sort of that vision is and what we can expect to see further for the cloud platform in the next 12 to 18 months?
Yeah, absolutely. So this is kind of like the greatest benefit that we've had is we can quickly iterate and update based on not a release schedule that happens every year or so, but within every sprint cycle. So right now on the API side of things, as I mentioned, we are building out the building blocks of OLI. So we started out with thermodynamics with OLI engine, then we added on OLI corrosion, but we do have a few more tricks up our sleeve, which we haven't exposed via those APIs. The first one is the ScaleChem product. So OLI ScaleChem is the most important portion of OLI ScaleChem is this mixing ability. So you're able to take multiple streams, downstream, ups, whatever, and then mix them together and get insights. Usually used for scaling. And so we're going to add the OLI ScaleChem capability, which is set up a few APIs with Mixer as the grand, offering. And the second thing is what I already talked about before is OLI Process API. So right now, as it stands right now, the only way you can actually talk to the OLI, Process API, which is our backend for process simulation, is via our application builder product. So there's an already UI, and that's the only way to access it. But we want to kind of open it to more general requirements. Your OLI Process API, which is essentially our process running tool, it will be the best bet. So it gets us one step closer to that digital transformation and one of the core building blocks of a digital twin, which is essentially the virtual plant. So you get a virtual plant with this API in a sense, and the added benefits, as I mentioned before, for example, optimization. The third piece is chemistry builder, is that we don't have currently the ability to generate chemistry models directly in the cloud right now. So you have to use one of our desktop tools. So this kind of removes that limitation. Those are the three things that are coming in on the APIs. We are trying to get into the automation space. We have talked to a lot of clients. We see a lot of use cases coming out of it. Every client is different, use case is different. So we do see a future in which our products are being used in a variety of ways, whether via digital twin, for automation, for AI. So this kind of sets the framework to make all of that possible. We couldn't do that before. Now we have a way to do it. Yeah.
This has been very illuminating, Arjun. Thank you so much. And we'll definitely have you back for another conversation sometime in the future. But thank you so much. And congratulations again to you and the team for all the hard work and the innovative development. We are eager to release V11 to our clients in the coming days here. So thank you again.
Thank you, Nick.